Our first speaker is Professor Robert Mackenzie, Professor of Atmospheric Science and the Director at BIFor at the University of Birmingham. And Rob's going to be talking about the green infrastructure and urban air quality. Thank you.
Right, so there's my talk, and the green before infrastructure is in brackets because really I'm going to talk today about the context in which urban trees find themselves rather than about urban trees themselves, but hopefully that will be important and relevant for you in making your planting decisions. This is really a summary of this document, which is available just over there. Please go and help yourselves. It is 4 sides of A4 in length. So it's a piece of what's known in the jargon as knowledge exchange, which was really the brainchild of Emma Ferranti. And Emma's not with us today, but I really want to pay tribute to the efforts that she's made in boiling down an enormous literature into 4 pages of A4, 4 sides of A4. I am just going to try, for the very first time, to boil even further down into 3 words. So let's see if this works. So the alternative title for this talk would be Air Quality Management in 3 words. Let's see whether it actually works that way. So the things I want you to remember from this talk are, so I was talking to a recruitment guy on the train. He was a very talkative guy coming down from Birmingham this morning. I had lots to do. He wanted to talk. 7:30 in the morning. And so these were the messages I gave him. So air pollution brings forward 50,000 deaths in the UK every year, as far as we know. Nobody writes air pollution on death certificates. So this is a statistic which the epidemiologists have had to dig into the statistics to try and work out. And of course, everybody dies. So really, when we're talking about causing death, we're really talking about death being brought forward. And there's another statistic which is equivalent to this from another committee in the UK, which if you prefer, we can use. Here are the 3 words. 3 words, I think, actually, it's only taken me 25 years of professional academic research to come to this point. This is actually what we need to do, particularly with respect to the urban air quality pollutants of concern currently. So there's a little bit of a caveat there, and I'll explain why as we go through. We need to reduce emissions. We need to extend the distance between the emission source, and whoever is breathing the pollution. And we need to try and protect vulnerable people, also vulnerable ecosystems, but here we're talking particularly about public health. So maybe it should really be 6 words, because these 3 words should also be in red bold, because I think it's the order that you do this that is the really organizing principle that might finally allow DEFRA to get its act together as far as air quality management is concerned. Anyone from DEFRA in the audience? Okay. So as part of that, as part of the whole of urban infrastructure, green infrastructure particularly influences the extend the distance and protect the people parts of pollution dispersal and deposition. I'll explain some of these terms in a moment. So you'll notice that the GI is coming in after the reduced bit. And I'm even tempted to say that you should do this in something like 100 to 10 to 1 kind of sense of importance. You know, it's that sort of ratio. That's where the effort should be. So we need to manage expectations around the benefit that green infrastructure can deliver, given that we have a very significant public health crisis. And that's just in the UK. Okay, so when you consume things, you, as an organism, lay yourself open to biological and biochemical threat. We take in about a kilogram of food every day. That could be spoiled or it could be poisoned. We take in about 2 kilograms of water, 2 liters of water. Again, that could be contaminated in some way. We take in about 11,000 liters or 11 kilograms of air. So we expose ourselves to a huge mass of air every day. And when that mass of air is not clean, that's when we begin to have problems. So that air that we breathe is often polluted. It is regarded by the WHO in its latest estimate as the biggest environmental risk to health globally. And the estimate currently stands at 3 million people's deaths brought forward per year. Almost everyone, 9/10 of people living in cities, are in cities that don't meet air quality guidelines. So it's not just a UK problem, it's a global problem. And of course, many of you will have seen pictures of, is that Beijing? I can't remember now, that's London. Of Delhi, Beijing, and these emerging economies where there are absolutely astronomical amounts of air pollution. But you think it's Manchester? It's Manchester itself. Oh, it is Manchester itself, sorry. I don't recognise Manchester, that's poor, having spent...
the image is by the University of Manchester.
Let's not concern ourselves. The image is certainly by the University of Manchester. Whether that is Manchester, no, far too green. I haven't got the new Northern Forest up there yet. Air pollution problems are something that stubbornly refuse to go away. You know, I mean, we've known about air pollution in urban areas for a very long time, since the 1950s in California and so on. Really, it's surprising that it's still refusing to go away in places like the UK. So, 50,000 premature deaths per year. Most of that epidemiology relates to heart and lungs, so cardiovascular diseases, and I'll come back to the pollutants that are associated with that just in a moment. There are a number of other areas where the literature suggests there are health effects, but none are quite as well worked out as the cardiovascular story. Okay, so particulate matter, microscopic particles in the atmosphere. That's what this thing refers to, PM2.5. They are very associated with cardiovascular diseases. There's about 20 units as an annual average in a UK city. If we take one of those units away, that would save 4 million life years for those born in the UK in 2008. That's the way the Committee on the Medical Effects of Air Pollutants expressed basically the same statistic as this 50,000 premature deaths in 2010. So there are different ways of thinking about these life years that are being impacted by air pollution. The pollutants that we care about in this context are these microscopic particles, so PM, particulate matter, oxides of nitrogen. The poisonous one is nitrogen dioxide, NO2, but it just turns out that it often interchanges with another oxide of nitrogen, so it's easier just to think of it in its collective sense of NOx. And then there's this other thing, ozone, and ozone is very significant for you as tree planters because you'll often find this being referred to as the reason why you can't plant trees, particularly why you can't plant high isoprene-emitting trees. And Andy mentioned briefly in his tree selector talk this morning that he flags up those places where biogenic, volatile, organic compounds are an issue. So they are emitted in high quantities by this particular species. I'll come back to that later on. For the moment, I want to concentrate on these two, PM and NOx. Road transport is the biggest source of the directly emitted pollution in urban areas. That's these two. And local authorities are the poor souls who have to manage this air quality, designate air quality management areas, and try and do something about it. And as I say, it turns out to be incredibly difficult to do anything about this air pollution. And most of the air quality management areas are actually for NOx, although a lot of the health literature that we now have in terms of health impacts are related to PM. So more and more what's happening is that we're looking at PM and NOx as the two things we really want to worry about in the UK, in urban areas. Okay, and this just tells you that, this slide just says that in this little booklet, there's a description of these pollutants. Let's not delay ourselves with that. The headline is, the biggest sources of directly emitted particulate matter in the UK are combustion and road transport. And then the biggest source of NOx in the urban areas is road transport. Again, so it's that combustion, internal combustion engine. Ozone is not directly emitted, but is produced by reactions that take some time to boil up on a very bright sunny day. I'll come back to that again later. But all of these, PM, NOx, and ozone, have well-established negative health impacts. So they're all bad for you. Right. This is the brackets green infrastructure bit. So it's important to realize that urban form affects air quality. Other planners and developers in the room? Or is it mostly, yeah, some, not many, just a few. I was talking to planners just the other day, and everything that we do in terms of setting out our urban form can have a big impact on air quality. And that's really one of the take-home messages from this document. Urban areas are where a lot of concentrated creativity happens and a lot of concentrated resource use. And there's a thing called the second law of thermodynamics, which means it's very, very difficult to have that resource use and creativity without creating waste. And that waste is what I call pollution emission. It could be other emissions, it could be heat emission and all kinds of stuff. But in our case, I'm interested in pollutants. Green infrastructure, especially trees, emit these volatile organic compounds. And we need to just remember that. But it's also important to remember that green infrastructure, especially when it's sort of extended in the urban fabric, so in parks and around, making long linear features, makes space for, it shouldn't really be clean air, it should be cleaner air. And one of the things I'm going to emphasize in the rest of this talk is that we need to be a bit modest about how clean we can make air. And that making space for cleaner air is just simply by dilution. So that's not getting rid of the pollution, but it is reducing the concentration of the pollution. And the health impacts are strongly related to the concentration. Sometimes with a threshold, but not always. And if you want to discuss that, we can discuss that offline. It's a little bit complicated. Right, other things that can happen is that everything in the urban form can act to form a canopy, just in the same way as trees form canopies in forests. And that canopy can hold air close to the ground. That's called fumigation if that air is being polluted. I'll show you an example of that later on. But the other thing that buildings and anything else in the urban form, and especially big trees can do, is produce swirls and eddies and mixing in the air. And what that tends to do, especially in our context, is move air that has pollution being pumped into it at the ground, because you think of cars and lorries pumping pollution out at sort of knee-high. It's moving that up into the rest of the atmosphere. That's a process called ventilation. And then there are related issues to do with moving things along horizontally. And then the last thing that we need to remember that anything in the built environment can do, but trees are especially good at, is actually acting as a filter and absorbing the pollution. And that's a thing called deposition. usually in the literature, in the technical literature. And that's the only thing that actually removes the pollution from the air. All the rest are about mixing it away, and so making the air relatively cleaner, but not actually getting rid of it altogether. And just to very quickly show you some examples of state-of-the-art sort of estimates of these effects. This is work from the University of Leicester. So this shows the center of Leicester, and the blues are where putting trees into the computer model, and this is the real treescape because they've used the LiDAR survey that was carried out some time ago. So when you put the trees in some places you get these decreases in this pretend pollutant, so it's a little bit like nitrogen dioxide, and in other places you get sharp increases in concentration. So they said themselves, blah, 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 blah. Trees increase traffic pollution concentrations in street canyons, but show a beneficial decrease of concentrations in open terrain configurations. This took a long time to generate this result. It's a hard piece of computing to do, and it's a complicated conclusion. So that's a bit difficult for us all to work with. Here's another set of similar results from the same group. And what they're showing here is the relative effect of trees and the deposition. So this is the mixing of trees, the stirring effect of trees. This is the filtering effect of trees, and this is grass. And what you see is for this situation where it's relatively windy, the trees mixing effect moves the pollution away in the atmosphere and causes a decrease in this particular, modeled PM. But if you drop the wind speed, you actually get an increase due to this balance between fumigation and ventilation. So again, that's pretty tricky stuff to do and tricky for you as practitioners to work with. One thing I'm often asked is, why do you always just talk about computer models? Why don't you actually go out and measure these things? And some people do measure these things, but I would just add a note of caution here that if you want to measure, for instance, the effect of this isolated tree on the pollution that's coming from this side, you need to do more than just measure here and look at the difference. That's what this is. Because the air does not just move in a straight line through that tree. You all know that, actually, because you've done enough biomechanics to be aware of that. But very often in the literature, you'll see this minus this being taken as the filtration effect of trees. It's not. You need to be aware of that. So what we've tried to do with the document is provide a little bit of rule of thumb practitioner guide that cuts through all this complexity. So see how you feel about these. So if you have this kind of street canyon situation where the trees are forming quite a dense canopy inside the canyon, then as long as the source of the pollution is outside, that's a very good thing. That is unquestionably, the air down here is unquestionably going to be cleaner than up here or over here. Okay? Might not be an awful lot cleaner, but it'll be cleaner. That's the only way, so it's a safe bet. If you have a situation like this where the pollution is under the canopy with the people and the trees above, then you've got a difficult calculation to do concerning the exchange of air between this airspace here, and higher up. And that actually you can only really currently do by computational fluid dynamics. So for those of you who are involved with developers, when the developers start trying to figure out whether the door in this building will open because of the swirling of air around and all the other buildings around it, that kind of CFD, that's what you need to do to solve this problem in terms of pollution as well. And they are, you've just seen some results from Leicester showing you that it's becoming operational, but it's going to be kind of expensive. So other rules of thumb. Large areas of green infrastructure, I've already mentioned this, have cleaner air just because they've got fewer emission sources and you're diluting air into that cleaner air. If you combine your urban form into a kind someone from the RTPI described it as kind of interestingly crinkly. So if your urban form is interestingly crinkly in the horizontal and in the vertical, that really helps mixing of air close to the ground. That's what this cartoon is supposed to denote. And that mixing is good at moving pollution away from the source, which, as I say, in urban areas is close to the ground, up into the atmosphere. Whereas if you've got very uniform urban form, then you can get the air skimming across the top, and you can get these kind of pools of relatively stagnant air, and if you pollute into those, the pollution just stays there, doesn't get diluted. One other way that GI can very definitely, in principle, play a part in the air pollution story is as a barrier, or an absorbing barrier, between the pollution source and what we call the receptor, the people that are going to breathe the polluted air. This doesn't have to be green infrastructure, it could just be a wall, but there might be reasons for making it. If you make it green, then there's the absorption on top of just the displacement that's happening here. And the process here is due to the fact that this is exactly the same physics as was used to argue for tall chimneys in the 1950s. So if you build a chimney taller, you just make the plume disperse more by the time it hits the ground. So it's more dilute, less harmful. If you give the air that's coming out of the exhaust pipe a longer journey to the lungs, then you can make quite a big difference because it's an exponential decay. So it's one of those ski chute decays. It goes down very quickly, very close to the pipe. Okay, so just making a few meters difference can bring that concentration down a lot. But do you think anyone will ever go for 100 meters of continuous hedge along a street? And look how high that hedge is. It's 3 meters, 4 meters high. So trouble might be difficult to actually get that get take up. Okay, this is a slightly more complicated attempt. Before I come back to the very simple than this. This is what we've been playing around with recently in terms of a stepwise way to ask yourselves the questions about green infrastructure for improvement of air quality. So you start by saying, I want to put some green infrastructure in my place, wherever my place is. And the first question you should ask is, am I doing this? Is this a new northern forest? Is this a new 1 million tree plant? If it is, you need to think about ozone. That's okay. That's kind of stuff we've been doing for decades. We can help you with that, but it's slightly technical, so you need to go around that red loop. If you're not, is the place you're interested in a place that's got emissions in it? If it doesn't, brilliant. Just stuff it full of GI. If it does, then you can ask yourself, is there a way I can create a green oasis? And you can think of that behind the hedge example as one of those sort of green oases. If you can, again, brilliant, stuff the place full of GI. If you can't, then you might find that you've just argued yourself to a position where really your GI is not appropriate for air quality. There might be all kinds of other things that your GI could be delivering, and I think we're going to hear from Anne later on that there's lots of things that GI can deliver. It's not just all about air quality. So don't give up on the GI just because it's not going to deliver air quality, but just recognize that. Or you may have to go the whole hog and pay a consultant $100,000 just to do some CFD. Right, so good urban design can mitigate air pollution. Consider air quality at all stages of urban design and development, and think about air pollution in terms of reduce, extend, and protect. And just to elaborate on that a little bit, this is right back to certainly first year undergraduate, perhaps even A-level geography. Pollutants, by and large, come from a source, travel along some kind of environmental pathway until they reach a receptor. There are some important exceptions to this. So if you're, things like PAHs and PCBs and things that accumulate in fat, we can't really take this approach. But for things like PM and NOx, don't think ozone, but for the other two we can. Think about, certainly reduce your source. That's the obvious thing to do. If you want to clean your air, then focus on the source. That's the reduce part. Once you've done the very best you can with that, then it's appropriate to think about increasing the pathway between this inevitable source, the source you can't get rid of, and your receptors. And only once you've gone through this bit and this bit is it really worth thinking about what can I do as a last resort to protect those people that I am, that are in the space that the place that I'm concerned with. There's quite a lot of help to be had. These are really just here for anyone who wants to look these up later on. So the slides will be made available later. And you can see TDAG right there in the middle. But the summary status, as far as I can figure it out at the moment, is that the direct experimental smoking gun evidence, if you like, of the effectiveness of green infrastructure is a bit scarce. Most of the knowledge comes from modeling studies, and that's for the reason I just told you about, having to be a bit more careful about how you make the measurements. Strategically designed GI shows every chance of from the computer models for mitigating poor air quality on local scales, where local might be just a few meters. And that's a good resource if you want. I can pass that paper to you if you're interested. But the thing to remember is that, and I've seen this actually argued in papers that wanted to be published in places like Nature, that you can offset pollution by planting trees. You absolutely, absolutely cannot do that, okay? So if you want to remove the pollution, you have to remove it at source. You can't. It's a bit like expecting, it's a bit like if you had the taps of your bath at one end and the plug at the other, expecting the plug to remove the water before it comes out of the tap. It absolutely can't do that. So GI can't remove all the air pollutants. The more dilute the air pollution is, the further it is away from the source, the less effective GI is. In certain circumstances, GI can exacerbate poor air quality. That's the fumigation issue, and we just need to be a bit careful about that. And then there is this VOCs issue, which might be an issue going forward, given what climate change is doing. But it's not all down to the trees, because it's not just VOCs that you need to form ozone. It's very definitely NOx and VOCs. So there are probably ways that we can mitigate this so that it's never a problem. And with that, just to say thanks, and there are some places to get the electronic version of the booklet is there, and that's the Twitter handle, and that's me. Thanks very much.
Right, our next speaker is Tijana from the RHS, Principal Horticultural Scientist at the RHS. And Tijana's going to talk to us about the provision of multiple ecosystem services by urban hedges. Thank you.
The reason I'm here is because for the last 8 years, I have researched for the RHS ecosystem services of various forms of green infrastructure. And particularly in the last couple of years, I've sort of spent a lot of time working on sort of hedges, primarily in the sort of domestic garden scenario, but there are some sort of overarching messages that apply to, green infrastructure in sort of other forms as well. Page down. How do I move this? Just like that. Excellent. So the sort of context of the talk is that there are a number of environmental issues that we worry about in towns. Here I've listed just some which are kind of more physical in nature, too much heat, issues with localized flooding, pollution, noise. I mean, the list can go on and on, depends on what your interest is and where you live. And I very much would echo what Rob is saying. Vegetation can help, but it's not the answer. It's an answer, part of the solution to the problem. But there are a lot of subtleties, and the intention here is really not to confuse you or discourage you at all from using green infrastructure. It's just to put a few as I progress in a talk, so sort of words of caution and also some practical advice as to what could be next. So the main sort of, I'd say, umbrella under which I sort of am working and the kind of line of thinking which I have is that, vegetation is very important, but the extent of cover and the choice of species is very important. And that sort of, again, very much resonates with what Henrik and Andrew are talking about. So really, if I was summarizing my work, if you just gave me a minute and one slide, this is what I would put up, because that really summarizes what I'm working on. I mean, it's not just obviously me in the whole wild world doing that, but in terms of, where my work fits, is that's the sort of umbrella. Plants, as a biologist, I'm very aware acutely that on a plant level you have huge individual differences between species in a number of parameters. Henrik and Andy have highlighted differences in water use and water potentials and all the other parameters they've mentioned. Pretty much any parameter you name it, you'll find a range, whether it's their capacity to sequester pollutions, whether it's their capacity to cool or, cold water in the canopy. There is a huge range available in nature of, how well or less well plants will do it. But I think what struck, as a scientist, sort of in my early years of postdocing, what I was obviously doing is you get funding, you study an individual problem. So I started with cooling, for example, plant water use and how that affects cooling. But then, you realize that's linked to the capacity to, trap rainfall. It's also linked to then some characteristics of plants, as you will discover when I go through it, are linked with the ability to trap pollutants or noise. So actually, and then you think, well, I'm really studying this plant for a single service, but it's sitting there doing quite a lot of things all at the same time. And that's where I come back to the point that Rob made. You can't, there are situations where you primarily need to fix a single problem, and then you need to, say, yeah, is this good for air quality or not? But if you're not in an area where air quality is a pressing problem, then I think you have a bit of a luxury to start thinking about other things that plants do, even if they're not super pollutant sequesters, for example. So basically, another thing that is important for me is that plants provide many simultaneous services. And really, the reasons why they do that is because they are different in terms of how they're structured and how they function. They function at very, very, very different levels, and Henrik and Andy have shown us some examples of that, and I'll show some further examples. And that's why we expect different things, certainly at the local level. Now, the work that I have done, as I say, over the last few years, and the work of my recent PhD students, and here they are here, Maddalena, Sarah, Federica, they worked on sort of various aspects of ecosystem services delivered by various types of plants. And, these are the kind of traits we've identified because, in a RHS plant finder, it's, thousands of plants. We cannot be testing every single plant. So what we are looking is testing a wide enough range of plants which are very different in terms of structure and function, and trying to pull out whether there are any overlapping traits which we can link with provision of good services. And for example, these are the things that Maddalena identified. She found it for cooling, high transpiration rates, so strong plants which use a lot of water and pump a lot out. They cool very well, light color, presence of hairs, large canopies, can be linked with better provision of cooling on a local scale, so sort of small plots. For pollutants, it's presence, that's particle pollutants, presence of hairs and rough surfaces, large canopies as well. For rainfall, there's a lot of overlap in terms of traits which are linked to both cooling and rainfall capture. So from that, I'm going to now sort of elaborate on each individual service, just to give you a sort of some sense of components of it. In terms of the cooling, there are four major mechanisms whereby plants provide cooling. shading, reflection. For me as a biologist, this is a really important mechanism, and that's through transpirational water loss. I mean, you can have artificial surfaces giving you this type of protection, but no artificial surface would provide you this evapotranspirational heat loss, which provides cooling. I mean, the fourth component is photosynthesis, but that's really negligible in terms of its contribution. So, and obviously, it's wonderful that, additional benefits that plants provide in cooling urban areas as opposed to artificial shade and reflective surfaces is there, but some caution is sort of advised. I know when I talk to my students, because I'm not a lecturer, but my place of work is University of Reading, so I have a small optional module for final year students and masters. And I really, my mission is that by the time they leave the university, they stop using the words like urban heat island, very lightly and without real understanding of what it is, and then making statements like, yes, trees can mitigate urban heat island. Well, they cannot if they're on their own. What you need, is, as everyone this morning was alluding to, is quite a large area of green infrastructure to mitigate, those big physical issues. What plants do, however, is they have clear localized effect, and it's not just my work; it's a host of research all around the world, which is showing clearly that plants differ and how you can rank them. The kinds of traits which are linked with better cooling are sort of large canopies, strongly transpiring plants. The work we've done in terms of the color, because light leaf color increases reflectance, shows that yes, leaf color to an extent is important, but it's only when plants are well watered. So, in very happy plants, your red tree will be, absorbing more than your yellow tree, and thus, there will be some local differences in temperatures. In terms of the next service, which is the sort of capture of rainfall, mitigation of rainfall by plants, the way that plants work is kind of twofold. It's passively really through retention of water on the canopy, and that is helpful in the sense that it does at least protect the drainage systems from that sort of initial raindrop, because some percentage, and it would depend on the size of canopy, intensity of rainfall, and other factors, will not reach the drains. But another very important way in which plants work is through kind of releasing soil's capacity to receive further rainfall, and then again, evapotranspiration, the same mechanism that's included in cooling, is very important. So plants which transpire more, which are, when I talk to kind of my audiences that RHS shows, I say, plants which are stronger pumps, which pump more water out of the ground, kind of replenish soil's capacity to receive further rainfall better than some others. So again, I mean, at the moment, RHS is in process of really revamping its website, adding a lot more environmental info, because we see that our members want that. So I've had just recently a very enthusiastic young colleague in a publishing department saying, okay, so I need to do something about hedges and flooding, and flooding will, having them flood the hedges will protect people's gardens from flooding. I'm like, no, it won't. It's kind of, and they hate it when I'm like that, because obviously I want to send a positive message about the importance of plants, which I'll come back to. But again, caution is required, because no amount of planting will offer protection from, once in a 100-year event, or if you're on a floodplain. But what it does do is, again, certainly provide localized effect. No one is arguing that a paved garden is better than, a green garden, because, you're retaining the soil there. You have all these other benefits. So you can certainly have, through, judicious plant choice, very positive effects from retaining planting, including hedges in the garden. Again, large canopies, strongly transpiring plants are linked with better provision of rainfall mitigation. And really, I think in this particular case of plants and rainfall, soil is kind of the main player, and plants are there really as the icing on the cake to kind of keep the soil in place and to help it a bit, act at its maximum potential. Am I being too fast, guys? I'm kind of thinking, oh my God, I'm getting really excited. And then I'll try and slow down, perhaps. The third service I wanted to mention here is, the air quality, and this is just a very reduced version of what Rob was talking about. In terms of hedges, the way that I sort of think of them when I'm researching is the position and dispersion role that they have, and in terms of the actual studies which I have done, it's really the kind of the position of particles, the PM, particulate matter, on various types of leaf surfaces. And my assumption is that, well, as Rob was saying, anything can act as a barrier. It doesn't have to be a hedge for the particles, but where vegetation or hedges, in this case, may have an advantage is because they have larger surface area, and some of the hedges also have surface properties which can be linked with capacity to capture and retain more. These properties are rough and hairy leaves. So if you have rough and hairy leaves, basically more things will just stick to them, and they'll be washed less easily. Large and open canopies provide good service, so you have to allow for some sort of filtering capacity, not a barrier which is impermeable. Evergreen hedges and vegetation generally better than deciduous. And basically, it's a local effect which is proportional to the extent of greenery. So, a meter of hedge isn't going to do much if it's very shallow and very, very low. But, an extended belt which is, 2 meters deep and 2 meters high may have, a few meters long, will have a local effect. But again, that's all set in the backdrop of things that Rob was talking about. It's only when it's applicable to install a hedge, so it's not, a solution for a very narrow, street canyon and a situation where you will not have enough mixing. Yes, but in that sense, hedges are possibly less, I suppose, troublesome because they can be trained in a way which is vertical and, would cause generally less trouble, I suppose, in that aspect. So that's kind of general. What I've been talking about previously wasn't all just, my own wisdom. It's sort of stuff I've accumulated by reading over the years and doing a bit of my own research. And what I'm going to go in between now and the end of the talk is some results from the last couple of years of the work that I have done on garden hedges. We've picked them up because gardens are very popular hedges are very popular garden features in the UK. A lot of people in this country have private gardens. We see an increasing trend over the last few years of vegetation, including hedges, being lost from front gardens because of paving. There is a number of very reputable literature sources which link loss of vegetation in the gardens to a number of environmental problems, increased flooding in front gardens, rise of temperatures and so on. So what I wanted to look at is seeing, the hedges which I know our members are growing and are very interested in, and also hedges that are currently on the market, and trying to choose sufficiently different types of hedges, see to what extent the difference in plant structure and function will kind of influence differences in how well those hedges capture rainfall, particles, and cool the building. So basically, I found that yes, it does. Choice of species does influence what plants can capture. I'm writing a couple of papers on hedges at the moment. So hopefully by the end of 2018, we will have published something also as a practical output on the RHS website as well, in addition to scientific papers. But this is, please don't lose sleep over exact specific species, but just to show you the range. So that's when it was all an artificial system where I've applied rain, through the sort of irrigation drip, and it's always the same concentration in same conditions and what have you. And that's the runoff from the soil. So in that setup, where I have watered my pots and then came back to them 3 days later and rained for a certain amount of time, I had 40% of runoff from bare soil, and I've had barely any runoff from the containers where I've had Cotoneaster hedge, and then also with hawthorn, crataegus, very little runoff. And then something like thuya, I had actually, I mean, it was still better than bare soil, but quite a lot of runoff from thuya. I mean, I've done more experiments since, and then I was beginning to sort of figure out why what's happening, and it looks to me like main explanatory variables are size of canopy and transpiration rate, so the water use by plants. In terms of the particles, it was an experiment I've set up in central Reading. I've just put some hedge plants along a very busy road, left the plants in there for as long as I could, without them being rained on, and just literally did a very simple experiment, washing them off and filtering and measuring the weight of dirt. I didn't do, next thing I will do is filter it with different filters to see the size of the particles, but this is the actual volume of particles altogether on the leaves. And you can see that, for example, some species, this is Photinia red robin, which has very smooth, waxy leaves. Very little was caught, and this is actually expressed per meter square leaf area, so that's normalized. But, per unit leaf area, there are some species that capture a lot less than some others. Cotoneaster, I was expecting to come up quite well because it has very hairy leaves, and I know when I looked under the microscope, a lot of things stick, but I was actually surprised by Taxus, there was a lot that was stuck on Taxus, and I think that's probably to do with the density of the canopy, but I'm kind of still thinking about the explanatory variable. I think it's just really to show that there are, differences between species. So what I'm doing that now with this information, again, that's just to, it's a bit of a show-offy slide. Just to say, I'm now putting it all in some sort of tabular form, stuff that I found, stuff that I've read, and trying to make some sense of, what's known. I've searched by species and services and so on, trying to see what do we know about each of these very popular species which are potentially useful here and generally in this type of climate, sort of Northwestern Europe, North America. What do we know? Where are we quite confident that, we can recommend certain things, and where are the gaps? I mean, that's the thing that we scientists tend to do, look for gaps. And this is where I am. That's one of the papers I'm sort of alluding to, so hopefully you'll see it kind of officially with a seal of peer review. But we can see that, services like pollution capture, there is actually a lot of information already out there. And a lot of it is on hedges, which is good, and a lot of it is urban-specific. So it's not on hedgerows in agricultural context where you can't really always make right sort of comparisons. So the case for pollution, I think we know already a lot about the properties, the types of plants, how they mix, what do you want, what do you not want to avoid. The paper that Rob alluded to, Professor Kumar's group at the University of Surrey, they've published a review paper last year, and that really is providing a lot of practical guidance on hedges and vertical vegetation when it comes to pollution. But there are some services where there are quite a lot of gaps, and this is not an exhaustive list. You can start adding other services. Those are just the ones that I've selected. But for example, we know that for rainfall management, there's very little hedge research, and if there is any, the one that is available, so there are 3 or 4 papers, but that's all in agricultural context, nothing really in urban setting where you need to think about. And then, surprisingly, not a lot of species-specific research when it comes to, very popular services such as biodiversity. We know that greenery is good for plants, and we know a lot in certain contexts, but not, for example, in the context of urban hedges. So what does all of this mass of information really mean for practice? Well, hopefully, as I said, there'll be a couple of papers coming out from us. I mean, I am really trying to finish them this spring and then obviously publish them as soon as possible. But then as soon as they're peer-reviewed, then RHS will publish a leaflet, I'm hoping by the end of this year, if I'm lucky with, how quickly they're accepted. But in the meantime, really, for those of you who are practitioners, needing to do something now before RHS leaflets and others come out, is, once you've met the criteria that Andy talked about, those primary ones about site suitability, cost, physiological characteristic, those sort of secondary issues of ecosystem services, think about the impact of plants and which traits do you want to have in those plants to improve the delivery of environmental benefits. And the kinds of traits we think is definitely perennial plants, plants who are there for a longer period so that, benefits can accumulate. Physiologically active plants, so that's sort of faster growing. Thirsty plants, as it were, so, with high transpiration rates. Light in color. Not, that wouldn't do any harm, although it's not critical. And then generally with rough and hairy foliage, rough and hairy canopies to aid the trapping of particles on the surfaces. That's a very simplistic way of doing it, but I think it's a start. And yes, that's really, before I shoot off, just to say, obviously the work's not just me, slaving on my own. It's a whole team of people behind me to whom I'm very grateful. So yes, that's all for me.